Today we're going to be talking about hardware for DaVinci Resolve. We're going to get into a little bit of detail on some things we're just going to touch on briefly, but just give a brief overview of what we're going to be covering. I'll do a brief, like 5-minute introduction just about Puget Systems, about myself, so you kind of have a background of where we're coming from. We're going to talk about the studio versus free edition a little bit, because DaVinci Resolve, it's a very wide user base these days. You got the high-end professionals, but you also have a lot of people that are more hobbyists or YouTubers or video bloggers or people using it for editing. So it's a very wide audience. So we want to talk about the free and the studio edition. Then we're going to get into the kind of the meat of things, the hardware. So what hardware affects performance, and then specifics for things like storage, RAM, CPU, GPU, and a few other random things. Let me see. There we go. So just kind of what do we want to accomplish? There's a couple of points. Our main goal is to arm you with the knowledge so that you can either configure a system, or just so that, if you're getting help from, people like us, Puget Systems, or whoever else, that you really just have the confidence that you are getting the right thing, especially if you're doing research online. There's a lot of testing and benchmarks and stuff, but they're very focused towards gaming, and every application is different, and especially something like DaVinci Resolve. A lot of that stuff that people recommend is just flat out wrong, or it's old. Stuff changes fast in this industry. And really, it's because we feel like it's important to understand the basics of all your tools. I mean, if you're a colorist, you still have to understand the camera, you still have to understand lights, you still have to understand all that stuff. And a computer is just another tool. It's another tool in your toolbox. And it's really important that you know at least the basics of what's going on, because then you can tailor your workflow to match, kind of the system you have, or maybe the system allows you to do separate, a different kind of workflow. So it's just important to understand kind of what's going on. And I will note, though, that this is very general information for Resolve. Resolve, more than almost any other NLE these days, is it's very wide. I mean, you've got the color grading, that's been industry standard for forever. But now we've got editing in there. We've got VFX. We've got like the Fairlight audio, and each one of those are slightly different when it comes to hardware. So we're going to be talking in very general terms for like a general Resolve workstation. Once you get into specifics, so if you do a whole lot of Fusion, that's going to change some recommendations, and we'll touch on that. But if you are in the market for a new system, we really, really, really recommend that you talk with one of our consultants, even after going through this webinar, even after if you read all of the information that we have online. There's just so many nuances, even once you get down to codecs and resolutions. So just keep that in mind. And if you have a question at any point, there is a little question and answer button you can hit, and you can put in a question. We've got Oscar, is I think technically the host of this webinar, and he can maybe answer some questions just on the fly if they're really relatively simple ones, or we'll hold them for the end, and then we'll do a larger question and answer. So if you got any questions about the webinar, make sure you toss it in there. Okay, so brief about Puget Systems. If you don't know who we are, we specialize in custom high-performance workstations. We really put an emphasis on consulting and support. I mean, in the end, the computer is just a box of parts, but it's about getting the right parts for what you're doing, and then what happens if something goes wrong. I mean, anyone can really build a computer, to be honest. I mean, it's kind of like Legos, but what do you do if one of the parts you get is broken, or what happens in the future if it breaks? So it's really about getting a partnership with our team of real people and dinosaurs. And our goal is really to just like free your workflow, make it so that you can do whatever you need to do without worrying about your computer. And we're partners with a bunch of hardware guys, Intel, AMD, Samsung, NVIDIA, all those big guys. We're also partners with Adobe. We do a lot of work with Blackmagic. So we really are in a nice place right now where we're large enough that we can influence the industry, but we're not so large that you're just a number to us. We actually know you by name. We get excited about the work you do almost more than the work we do. And one of the things we do a little bit differently is we do have specific models of like our computers, but we really try to lead from a software first kind of approach. So if you go to our solutions page, we have systems for DaVinci Resolve, and it's just, there's the systems that are best for DaVinci Resolve. And again, like I was mentioning before, every software, like once you get into the details, it gets kind of complicated. So we do have like these presets and things we recommend, but almost always you should talk with one of our consultants if you're actually in the market for a system. We also do a whole bunch of testing here. So we actually have a public DaVinci Resolve benchmark you can download and run. And we publish a whole bunch of benchmark results whenever like Intel and AMD launch new CPUs, or NVIDIA launches new video cards. We do other testing for things like RAM and storage. And so if you want to really get into the meat of like why we're making these recommendations that we're going to be making in this webinar, you can go and dive deep into our hardware articles. And you can filter on the left there. There's a filter so you can say, I only want to see DaVinci Resolve if you don't want to see all of our other posts, because we put out quite a bit of content. And it results in huge amounts of charts and numbers. So if you love numbers, it's perfect. This is actually just from one DaVinci Resolve article, is all of these numbers. That's how much data we have to sort through before we get to like a single chart like this, where we actually rank different CPUs or GPUs for DaVinci Resolve or Premiere Pro or whatever other application you're using. And the reason we do all this testing, is because every application is different. I mean, so many of the hardware reviews, if you go out and read reviews, they're focused on gaming or general purpose computing. So they'll use what are generally called synthetic benchmarks. So they're not actually a benchmark for a specific piece of software. They're more, nebulous. The performance of this part is, X. And the reason why those don't really work is because every application is different. So this is just a quick, I not made it up, but it's a little bit of arbitrary scales. And you can see like After Effects and Fusion are very single threaded on the CPU. So a CPU that's great for After Effects or Fusion is not actually going to be great for Premiere Pro or everything else that's in DaVinci Resolve. At the same time, like Premiere Pro is pretty across the line, or not normal, but uses different hardware pieces pretty evenly. And then you've got like DaVinci Resolve that you want a little bit higher core count CPU, you want a little bit more GPU power or multiple GPUs, depending on what you're doing, of course. And so it really just, there is no one size fits all. And especially when you start talking about multiple applications, say you use After Effects and DaVinci Resolve, or DaVinci Resolve and Premiere Pro. That's where you have to start making decisions of, well, do I give up a little bit of performance here to get a little bit more there? There's always a give and take between things. So just keep that in mind. And keep in mind that what we're going to be talking about today is all just pure DaVinci Resolve. So if you do have a mixed workflow, you have to keep that in mind. It is something you have to consider. Okay, so, excuse me, the Studio Edition versus Free Edition. This has been coming up more and more for us. I have no idea what the breakdown is for everyone watching this webinar right now, but we're starting to see more and more people using the Free Edition. And it's honestly a great move on Blackmagic's part, in my opinion. It gets a lot of people into their ecosystem very easily. It lets students really learn. It lets people who are doing YouTubes or video blogs or home movies, it gets them experience with it. And then once they get up into the higher professional, they can move up to studio to get all the extra features. But we do want to break down for those people that are on the Free Edition, what are the kind of limitations that you're dealing with, just so you are aware, because they don't always make it super clear. And this is kind of our list of the ones I usually point out. There are others, but the main ones here, it only supports a single GPU. You can only do 4K. There's no GPU accelerated H.264 support. You can't do 10-bit. No multi-user collaboration, which probably isn't a big deal if you're doing the Free Edition. And then there's things like noise reduction, motion blur, lens correction. A lot of the open effects are not supported. In the context of this webinar, it's really these two that are the big ones. So the fact that it only supports a single GPU, so it doesn't matter if you've got 4 super high-end GPUs, it's only going to use one of them, and the no GPU accelerated H.264 encoding and decoding, and that actually is by far the most important, I would say, even more than the fact that it only supports a single GPU. And that's strictly because most of the people that are using the Free Edition, they are using H.264. They're either recording like screen capture things, whether it's for esports or webinars like this, or they're recording from cameras that only support H.264. And that's a big deal. No GPU accelerated encoding is really a big deal. We've done some quick testing, and it's about 10 to 20% performance that you lose by not using that. And that's on a fairly mid-range system. If I remember right, it was like a 9900K with a 2080 Super. And well, I guess that's kind of mid high-end system. And that's a lot, 10 to 20%. For $300 for the Studio Edition, that's more performance than you would get out of a $300 hardware upgrade. So keep that in mind, that if you are one of those people that are on the Free Edition and you want to get more performance, you're probably better off just spending that $300 to get the Studio rather than trying to upgrade your CPU or GPU or storage speed or things like that. Most of the time, just get the Studio Edition. So that is one thing to keep in mind, is that your computer isn't everything. There's the software you're using, the version of the software you're using, the codecs you're using, and your general workflow. So definitely keep that in mind. Okay, let me check for a second. Okay, so really into the meat of this, what hardware influences video editing performance. And this kind of applies to everything. It's not just video editing, obviously. It's going to be color grading. It's going to be VFX. Honestly, this stands even for things, anything else your computer might be doing, motion graphics or just graphic design. But it kind of works out to this. And sorry for my poor graphic skills. I'm not a graphic artist. I am a computer guy, but this is the best I can do. But it basically, you have that kind of this building or pantheon that all goes to hold up kind of the experience of editing, because it's not always just performance. Sometimes the performance is the same between two systems if you're talking about just raw like export speed, but it's with the things that make you more able to stay just in your creative flow and not being a distraction. And at the bottom, the kind of the foundation of these is going to be anything that's storage based. So storage for just like files, whether it's internal or external, and then you've got RAM or system memory, so that's temporary storage. And those are really the things that you have to nail first. If you don't have that, it doesn't matter how fast your CPU is, it doesn't matter how fast your GPU is, you're gonna run into problems. And that's easiest to kind of realize when you talk about storage. Like if you don't have enough size to store all your files, well, you're kind of out of luck. Good luck. So that's kind of the foundation. So that's the ones we're going to be talking about first. And then you kind of go up kind of to like these pillars that really hold up the experience. So it's past the foundation. Now you can start talking about performance or things that are going to make you more efficient. And CPU and processor is always the one I always start with. With DaVinci Resolve, you can make arguments that the GPU is the first one, but the CPU is generally where I start. And then you get into video card, like I just mentioned. So the video card, more and more these days, is a major factor for performance. DaVinci Resolve, it's been like that for quite a while, but even if you use Adobe products, After Effects, Photoshop, Premiere Pro, it's becoming more and more important as well. It's being a bigger deal when you're talking about how much performance you can get out of your system. And then kind of there's just everything else. Most of the things that kind of fall into this category are not about performance as much, but you're talking about things like displays, speakers, audio, all that kind of jazz. And that all goes to hold up the editing experience. So how efficient can you be? How much work can you get done? How fun is it to get that work done? Because it's not fun to deal with, program crashing, once an hour, even if, you could just hit save every 2 seconds, but that's not really great. So we're just going to go through these one by one, and we'll just talk about it. So at the very bottom of the foundation is storage. This is probably the easiest one for people to understand. I mean, it's your storage. It's where all your files live. It's where your OS is, applications, and all that kind of jazz. And one of the things, though, to keep in mind is that not all storage is created equal. There are multiple kinds of storage that you can be using. And the main three, typically, that you're going to be dealing with is going to be platter drives at kind of the I guess the slowest end. It's not really low end, but it's the slowest end. But they are really, really affordable. They've been around forever. It's a tried and true technology. Excuse me. And you can get them very large. They're now available at 14 terabytes per drive. And that's huge. You can fit a lot of stuff in that. They're even relatively fast these days, about 200 megabytes per second. Some of them are a little bit slower if they are geared towards like low noise. Some of them are a little bit faster if they're geared towards high performance. And that's pretty darn quick. Like if you're just doing like 1080p video, that's probably fine. You can run things off there, or they work great if you have some stock footage that you don't use too often, but use it enough that you kind of want to keep it on your computer local, or stock graphics or things like that. It's great for that. In general, though, we recommend it for like backup archiving, that kind of deal, whether it's internal or external. And then you have a step up from there as SATA SSDs or solid state drives. These also now have been around for a decent amount of time. They're very, very solid. In fact, we did a recent report recently where we looked at the failure rate of all the different core components that go into our computers. And SATA SSDs, or not even SATA SSDs, just SSDs in general, were easily the most reliable component in our systems. They were more reliable than CPUs, more reliable than GPUs by far. And so it's amazing how reliable they are, and they are more reliable than platter drives. Now, I am talking relatively short term here, like 3 to 5 years. If you're going long-term storage, archiving, that's where you get into specialty hardware that you're going to want to be using. But they're great. They're amazing. They are more expensive than platter drives. They are available in a lot smaller sizes. It is getting larger and larger every couple of years. They go up in size, but they're pretty quick. They're more than twice as fast as platter drives for like file copies or sustained reads. But the main thing is that they don't have any moving parts. So they have essentially no seek time. And that's a really big deal for making your system really feel like snappy. So that's the big thing about SSDs, is they make things feel snappy. Plus, they're faster. And they're just good general purpose drives. They're great for OS, your media, cache, kind of anything. Anything that's can go on an SSD, and you're going to be pretty happy. And then you have a step up from that, is these relatively new NVMe drives. They come in a whole bunch of different form factors. M.2 is that one that's kind of like a stick of gum. U.2 uses a cable to connect. PCIe, kind of like video cards. They are more expensive, again, than SSDs. They're about 50% more expensive. They come in even smaller sizes, so it's harder to work with them if you are doing like really large projects. But they're really, really fast. 3.5 gigabytes a second read is what they are up to. And so that's 7 times the performance of an SSD or a SATA SSD for 50% more price. Like, that's really, really amazing return. But the thing is, normally your storage is not the bottleneck once you get up to a SSD. It's really only if you're working with really high bitrate RAW, some 8K stuff, that you really should have them on an NVMe. And you can get around that somewhat. You could use a RAID of SSDs instead of an NVMe. RAID, we generally try to get people away from unless they're doing something very high-end and they can afford a high-end controller, simply because RAID breaks, honestly. RAID will break more often than your drives will fail. So that's just another thing that you have to worry about in your computer. But yeah, these NVMe drives are great. If you have something with a whole bunch of like cache files, it can be great. It can be great for like a fusion kind of work. But yeah, they're great. They're fast. They're just unfortunately not available in very large sizes quite yet. So kind of the questions to consider, what are the main ones we talk about when we are trying to steer people through what storage they should get? First of all, capacity, straightforward. You've got to have enough space to hold all your files. And that's just different for everybody. So there's not really anything to cover here in terms of a general webinar. Speed, though, is very important. What we generally tell people is figure out the bit rate of your media, add 50%, and that's per user. So if you're working off like a NAS or a network-based storage, each user has to have that amount of speed available. One thing to note is that media, when we're talking about bit rate, it's usually reported in megabit per second. Storage is often talked about in megabyte per second. And you need to know that because there are 8 bits in 1 byte. And so that's just a computer conversion thing. So if your media is 400 megabit, that doesn't mean you have to have a 400 megabyte per second drive. It's a lot less. A couple examples here. 4K ProRes 422, it's about 500 megabit or about 60 megabytes per second. Add that extra 50% to account for like overhead and things like that. As long as your drive is about 100 megabytes per second, you're good, whether that's internal or external. 8K Red, however, is about 2000 megabit or 2 gigabit or 250 megabyte. Again, these conversions are really annoying to have to do all the time. And that works out to about 400 megabytes per second of storage speed that you ideally want to have. And that's a very important number because you'll notice that that's way faster than a platter drive can sustain, at least a single platter drive. And it's starting to get close to the speed of an SSD, what's capable of that. So you might actually every once in a while run into an issue with that. Probably not, because it's still, even with that 50% buffer, you should still be fine, but it's starting to get a little close. And then last up with storage is the connectivity. We always encourage internal. I mean, that's really our focus is workstations, and so internal storage is best, but it's not always practical. It has the fewest problems, but it's the hardest to upgrade. You can't just like grab another external drive. If you have multiple users, well, excuse me again, that's not always going to just work. One warning we do have is if you do go external, whether it's with USB or Thunderbolt, or if you've got really old stuff and you're on FireWire, is that Mac OS and Windows conflicts are very common. There is software out there that lets you read Mac formatted drives on Windows and Windows formatted drives on Mac. Paragon is one of the ones we tend to recommend, and it seems to work the best. But even that software, it has issues. I would say that it's great if you're transferring files between two computers. Perfect for that. But if you actually want to work off of a drive and it's having to go through something like Paragon, we've had quite a few customers who they've tried to do that, and it just results in little issues. Like the drive drops for a split second, and then that causes Resolve or Premiere or whatever to kind of freak out. So definitely be warned that that kind of stuff is a little bit problematic at times. It doesn't always work as ideally as we would want it to. Unfortunately, computers are computers, and there are things that don't work quite right all the time. And if you have a workflow like that where you do have Mac OS and Windows, our recommendation these days is to try to work towards network-based storage. Not everybody can afford that. Sometimes getting a bunch of smaller USB drives is a lot more cost-effective. But network storage is really the best way to go if you're worried about compatibility and things just working. And if you do go that way, you lose the issues of like the Mac OS and Windows compatibility conflicts. It allows you to use multiple users. The biggest thing, though, is that NAS units are not typically going to be as fast as something like Thunderbolt or USB 3.0 or 3.1. So you do have to make sure that the connectivity is fast enough. It doesn't matter how fast the NAS unit itself is if your connectivity is not going to be up to snuff. And that is usually talked about in either gigabit or 10G networking. And in general, a single gigabit should be fine for 4K media, and if you're only like one user, you might be able to get away with 2, depending on how much stuff you guys are accessing at the same time. But if you're going to have more users than that, I'd say 2 or more, or if you're going to be working with 8K or raw footage, even at 4K, that's when you really need to go up to 10G. And some of the higher end 8K stuff, you might even need to look into even higher end than that. You can get into like fiber and things like that. But 10G is not that expensive anymore these days. All of our workstations can support it, and a lot of NAS units now support it natively. So I would just recommend, if you are looking into getting a NAS, make sure it supports 10G. Just look towards the future. It's not going to cost you that much more, most likely, so just go for it. And we will mention that if you don't have a NAS unit, you don't know any companies, you don't have any familiarity with them, LumaForge is one we've worked with quite a bit. There's tons of other brands out there that are terrific. But LumaForge is currently our go-to recommendation. So if you just need one name and you just want to have somewhere to start, there you go. Go with LumaForge. Okay, so we made it through storage, and now RAM. RAM is one that I don't think a lot of people understand quite as much as they understand storage. It's not quite as straightforward, but you basically think of it as it's just temporary application data typically. Fusion also uses it to cache frames, so when you play back any frames that can be cached, it doesn't have to re-render those frames. But it's temporary storage. And so what to consider, there's really not too much here. Capacity is really it. Don't worry about RAM speed. There are some times where RAM speed will make a slight difference. Honestly, I wouldn't worry about it that much. More often than not, going higher in RAM speed results in just your system blue screening more often. So generally, we don't recommend going anything above what like your CPU natively supports. But for capacity, if you want starting points, this is kind of where we would go. If you're working with 4K media or 1080p, I'd just go 32 gigs. That's generally our entry. RAM's getting so cheap these days, you might as well just do that. If you're going up to 8K, 64 gigs should be fine in Resolve. I will note that if you use Premiere and Resolve, like you're going back and forth, Premiere uses more RAM or needs more RAM than Resolve. So if you're doing 8K work, you probably want to go up to 128 gigs simply for Premiere, not as much Resolve. And then Fusion, it's really as much as possible. This also applies to After Effects. Same thing I was talking about before, it caches frames into RAM. So the more frames you have in RAM, the less you have to re-render things as you're looping through, playing things, adjusting things. There is another consideration is ECC or registered ECC memory. This is a special type of RAM. It's error correcting RAM. So it corrects hardware errors. This doesn't help you really as much if like the stick is failing, but it does help you for things like solar radiation comes down and it flips a bit on your RAM, and sometimes, most of the time, it's no big deal. Like that little bit was not actually all that important. But sometimes it can be catastrophic, and ECC RAM prevents those bits from flipping, or it has correction built into it. It's really only necessary for mission critical. So it's a little bit more expensive than normal RAM. It also requires very specific CPUs for it to work, which are often more expensive than the CPUs that you would normally use for something like Resolve. And in general, it's not worth it. If your system, like if a single blue screen or a system being down for a few hours costs you, thousands and thousands of dollars, well, yeah, you might want to invest in it. Most of the time, though, for our customers, it's just not worth it. They'd rather take that money and spend it on something like more GPU power or more CPU power so that they're more efficient always. And that, kind of makes up the time for that one random time, once every 5 years that the system blue screens or something like that. And that's really all there is to RAM. That's it. Just get enough. And so now we're going to move up to performance. Looking here, I've got about 20 minutes before we get to the Q&A. And reminder, there is questions you can flag if you've got any questions. But so getting into the performance side of things, you've got CPU, you've got GPU. And a lot of times people talk about them almost like it's a competition between the two. Like they're kind of fighting. And again, excuse my really poor drawing skills. But yeah, a lot of people, it's like a versus. It's us versus them kind of thing. But it's really not. It's they're happy. They work together. It's all good. Yeah, it's a partnership between the two. It is not a versus. You can't just like go crazy on one and ignore the other. Like you really need both, especially in something like DaVinci Resolve. So starting with the CPU, DaVinci Resolve is known for its GPU performance or its GPU utilization. So a lot of people ignore the CPU or don't give it as much thought as they really should. And it's really, really important. Like it's as important as the GPU. You just have to just keep that in mind. And so what do you want to consider when you're looking at a CPU for DaVinci Resolve? Well, the first question we always get is AMD or Intel. So both AMD and Intel make really great products. And how it breaks down right now is that Intel is going to be much faster at the high end. So this is going to be where you're getting into Intel's X series or their Xeon W versus AMD's Threadripper. Right now we're on Gen 2. And right now Intel is just straight the way to go on the high end. AMD's Threadripper CPUs, for whatever reason, don't actually work all that well in Resolve. So you really want to go with the X series. But if you're going for more of a mid-range, you're talking about like Intel's 9th gen CPUs or the AMD Ryzen's, that is where AMD is faster. So it all depends on where you are in like budget, pretty much, and how much performance you need. Intel on the high end, AMD is faster on the mid-low range. And oftentimes it's not by a huge amount when you're talking about the low mid-range. It's just a little bit faster with AMD. I will note though that there are other considerations. Things like Thunderbolt. If you are going to be using Thunderbolt, that's only officially or certified on Intel platforms. There are a few AMD motherboards that allow for Thunderbolt, but it's not certified by Intel, who controls Thunderbolt. So it's not always going to be guaranteed to work well. And we've been dealing with Thunderbolt for years and years, and honestly, it can be a nightmare on PC. We have to be very specific in what motherboards we carry with Thunderbolt and do a whole bunch of testing to make sure it works properly, because on PC, you can get into a lot of trouble very quickly if you are using a board that is not quite up to snuff for Thunderbolt. I've got an extra bullet there for some reason. Then when you get into, if you are going to be on Intel for like the high-end stuff, you've got the Core versus Xeon lines. So Core is kind of their consumer, I guess, line, and Xeon is their workstation and server stuff. And really, the performance between those two lines can be on par. I'm not talking about the same performance per dollar, because Xeon's a lot more expensive, but you can get the same performance out of both. And that's, I bring that up because in the past that wasn't true. You could get a lot more performance out of the Core line than the Xeon. But the most recent Xeon Ws, which are technically out, but there's not really motherboards, so no one is actually listing them yet. But those Xeon Ws are as good as Core when you're talking about just straight performance. Xeon does enable ECC memory, so we were talking about that before. One of the bigger things is actually that it allows 64 PCIe lanes on this most modern edition. And that's very important for Resolve, because if you are getting up into 3 or especially 4 GPUs, each video card really ideally wants 16 lanes. So 16 divided by, or 64 divided by 16, that allows for 4 full-speed GPUs. So that can be very important if you're looking for a very, very high-end Resolve workstation. But like I talked about, price, Core is typically a lot more affordable. So you're going to be getting a lot more performance per your dollar by going with the Core line. The other thing we always talk about is, hey, is more cores more better? Marketing from Intel and AMD and just a lot of people on the internet really love core count. And yeah, it to a certain degree, more cores is better, but man, it's nowhere near as much as marketing makes it out to be. Just as an example here, 10 core, this is an X series CPU to an 18 core. It's about 15% more performance. So you're almost doubling your core count and you're getting 15% more performance. So yeah, keep that in mind. It's yes, it can help, but it is not a linear kind of relationship. Oftentimes the frequency of the CPU, the cache, general architecture makes more of an impact than core count. Going back to this 10 core versus 18 core, that 15% is probably about the same you got by going just like, if you went back one generation, it's probably about 10% if you had the same core count and frequency. So, going up in that many cores is about really only the same as like changing one architecture. So keep that in mind, is that you can't just look at core count, especially if you're looking at like a older CPU because you can get it for a better deal. Like, great, it could have the same number of cores as a modern CPU, but it's going to be quite a bit slower. So here's just a chart from one of our recent testing. It's kind of a truncated. I took off a bunch of stuff. And if you want to get into the close details, you can go to the article is listed at the bottom. But I don't want you to worry about specific results here. The main thing I want to point out is that between the fastest CPU we've tested and kind of what we would generally consider our entry line for something like DaVinci Resolve, it's about 45% is the difference between the two. So keep that in mind. That's going from like I want to say it's like a $300 CPU to a $1,500 CPU. I'm not in sales, so I don't know exact numbers. But so it's a huge price increase, and you're talking about 45%. Now, that can be a very significant difference when you're talking about things like live playback. Like, 45% can be a major difference if you're talking about like being able to play something back at 24 FPS versus what is that, like 18 FPS. Like, that's the difference between smooth and choppy. So oftentimes you just have to find right where that level is for your performance. And the other thing to note here is that you often get these plateaus. So you'll notice kind of like in the middle or lower middle, you hit a point where like each CPU is kind of the same. And so it's important to know kind of where those are, because then like, hey, you might as well get the lowest end one on that plateau, because like you're going to get the same performance for less cost, which then you can spend on things like GPU. So what do we recommend? So this is kind of, again, generalities I'm talking here. But if you're looking for just a solid option in a couple of different like price points, this is kind of a good starting point. So if you are kind of on a little bit more of a budget, I mean, a lot of people would consider this a very high-end system, but whatever. But if you're doing like 4K work, consumer class stuff would be like the 9900K or the 3900X from AMD. Performance between those two is relatively similar. The AMD is a bit faster for most stuff. The Intel can be a bit faster if you use like a lot of OpenFX or noise reduction. It can be a little bit faster, or at least really close. And on the workstation side, so if you need that ECC, if you need the 64 PCIe lanes, that's where you get into the Xeon W, the 3225 8-core. And note here, performance is about the same between all of these, and the Xeon W is about twice the cost, or a little bit more. So keep that in mind. You are paying for that those features of like 64 PCIe lanes. Mid-range, so if you're doing 4K work, maybe a little bit 6K, or again, you're getting into just harder stuff. The 9920X X series from Intel is terrific. Or on the Xeon W side, you go up to about the 3245. And that's about $800 more. They're roughly the same performance. I believe the Xeon W is actually slightly faster. But, we're talking generalities here. We're kind of rounding things out to make things easier. And that's going to be about 15% faster than the 9900K or than 3900X. And then at the high end, kind of, this is where we would say you kind of plateau. there's really not much of a reason to go beyond this. And it's going to be like the 9960X Intel or the 3265 Xeon W. And those are about 25% faster than what we're talking about on like the budget line. Now, I will note that there is a higher end X series. There is a 9980XE 18 core, but in all of our testing, it's like 1% faster for an extra like $500. So that's really the point where you hit diminishing returns. There is also things like dual Xeons. A lot of people will be looking at. Those were terrific in the past. We used to sell a bunch of dual Xeons for Resolve, Premiere, and all those kind of guys. Even After Effects actually used to really benefit from it. But these days, with the core counts we're able to achieve on a single CPU, software just isn't efficient enough at using all of those cores to make like something like a dual Xeon effective. Oftentimes a dual Xeon is going to be slower or on par, but you're going to be paying a lot more money. So in general, dual Xeon, I would not recommend that unless you have a very, very, very specific workflow that you know is going to benefit from it. But in general, it's not going to work well. So that's kind of CPU stuff there. And so I think we will, oh, that's right. And if you do a lot of Fusion work, Fusion is unique in Resolve in that it really only uses a handful of CPU cores, oftentimes only even one. So you're looking at for the CPU that will give you the best single core performance. And this is not just a Fusion thing, it's kind of a motion graphics thing in general. This applies to After Effects as well. So if you do use After Effects a lot, something like the 9900K is actually the fastest CPU for Fusion or After Effects. The 3900X from AMD is very, very, very similar as well, so you can really go with either one. But so if you do a lot of Fusion work or a lot of After Effects work and that's your bottleneck, you might want to just go with that. Save your money and just get that because it will be the fastest. In general, these other higher end CPUs are going to be, I believe it's somewhere in the range of 10 to 15% slower than the 9900K. So keep that in mind that, you know, spending more money doesn't mean it's always going to be faster depending on what you are doing. Okay, so moving on to GPU. Now, Resolve is kind of almost famous for its utilization of video cards or GPUs. So it benefits from a powerful GPU, multiple GPUs. If you have the Studio Edition, again, remember the free edition only uses one. And so, yeah, it's a very, very important, more than any other NLE, I would say. You need to think about GPU performance. So things to consider. Again, brand is a big one. Almost always we get asked, AMD or NVIDIA. Right now, with the latest cards that came out, NVIDIA did a refresh. Now they have their Super cards, NVIDIA Super. And those cards really allowed AMD or NVIDIA to take the lead. So right now, NVIDIA is generally at better either performance per dollar or just overall. Like you're just going to get better performance for the same dollar and overall with NVIDIA. The only exception to this is there is a special card from AMD called the Radeon 7 or VII. That card is kind of odd though. It's really hard to find. And we've had stability issues that we've never actually been able to resolve. So we've never actually sold that card ourselves because we've had concerns about availability and stability. So keep that in mind. But if you are looking for the best possible performance for your dollar, that card is actually pretty darn amazing. And then there's Quadro versus GeForce on the NVIDIA side. So this is similar to the Core versus Xeon from Intel. It's basically their consumer-ish line versus their workstation line. GeForce is a lot cheaper, but it has less VRAM, which means if you're talking about like an 8K workflow, it's generally not going to have enough video memory. So you are generally relegated to 6K or definitely 4K workflows is where GeForce you're going to be using. Quadro has more VRAM, so it's great for 8K work. It is a little bit more reliable. Our stats, when we most recently looked it up, is about 15% more reliable. Now, 50% sounds like a lot. Both GeForce and Quadro are under 1% failure rate for us, so like it's actually a small fraction, but it is more reliable. So if it is a mission critical system, you need to have minimal downtime, and any downtime costs you a whole lot of money, more than the Quadro costs you, then you can go with Quadro. It does also tend to have fewer driver issues. The driver issues aren't as quite a big a deal anymore. NVIDIA has launched what's called Studio drivers for GeForce that has some of the software validation that the Quadro lines get. And then in between, you have the Titan line. Titans kind of switch, each model goes back and forth between being closer to GeForce and being closer to Quadro. Biggest problem with that card is that the cooler design means you can only use about 2 cards max in a system. So if you're going for a really, really high-end system, it probably is not going to cut it. You're going to have to jump up to the Quadro. And just like system memory, you need to have enough video memory. For Resolve, it tends to work out that if you're just doing 4K projects, 8 gigs is fine. And honestly, any mid-range card is going to have more than 8 gigs, so you're probably going to be fine. If you get to up to 8K projects, that's where you need a lot. It's a big jump. About 20 gigs is how much you want. And I'm not talking about the media you're working with, but the actual like resolution of your timeline is generally what determines this. And again, just putting up a chart just so you can kind of see the relative difference between different cards. If you really want to dig into it, again, the article is listed down there. But similar to CPU, it's about a 50% difference between the fastest CPU or GPU you can get for Resolve and kind of what we would deem the lowest end that we would be comfortable using. And do note multiple GPUs. Resolve can support it on the Studio Edition. But if you're just doing basic grading, maybe editing, Fusion especially, you're not going to see a benefit. It's really once you get into noise reduction, and especially OpenFX. If you stack OpenFX, multiple GPUs can make a really, really, really big deal. So just keep in mind what you are doing. The more OpenFX, the more noise reduction, the more multiple GPUs will help you. All right, so I'm going to have to go a little bit quicker. I think we're going to end up going a few minutes over. But so what do we recommend? Budget. So this is like if you're doing 4K work, 1080p, and you don't use much OpenFX noise reduction. The 2060 Super from NVIDIA is a terrific card, or on the workstation, the RTX 4000. The RTX 4000 will be slower than the 2060 Super, so keep that in mind. But we're kind of trying to give you the best possible performance in each of these like budget ranges. Mid-range is where you get into possibly wanting multiple cards. So if you start using OpenFX or noise reduction a little bit more, that's where you get into like the 2080 Ti from NVIDIA, either 1 or 2 of those, or a single Titan RTX is about the same cost as 2 2080 Ti's. The Titan RTX generally you'd be using if you do like every once in a while you do some 8K work. And then on the Quadro side, you got the RTX 5000s, and again, you're going to be slightly slower than the NVIDIA GeForce cards, but they're also a lot more expensive. So we tend to not try to go for the same exact performance on each one of these levels simply because of the cost. And then high end, if you're doing up to 8K work, a lot of OpenFX, a lot of noise reduction. Maybe you do like a splitter node and then do noise reduction separately on the red, green, and blue channels. This is where you get into 3 to 4 RTX 2080 Ti's. We do that very commonly for people that are doing like 4K even, but really, really heavy OpenFX or noise reduction. Or you can go up to 2 Titan RTXs. And again, I mentioned this before, those cards, because of how the cooler is designed, you can really only use 2 cards of those maximum, or else they're going to overheat and then end up being slower than a lower end card. Or on the workstation class side, that's where you get up to the RTX 6000. Tons of VRAM, pretty good performance, very expensive. There is a higher end RTX card or Quadro RTX called the RTX 8000. And that is basically the same thing as the RTX 6000, except it has double the video memory. So it has 48 gigs of RAM. Not really a big deal for Resolve. Once you get 24, you should be fine on anything you're doing unless you are doing something really, really crazy. So one thing looking towards the future, I bring this up a lot recently. It seems like I'm kind of repeating myself because it's taken so long for it actually to come to fruition. But Red and NVIDIA are working on an update to move more of the processing of Red raw to the GPU. So right now, the GPU is used for debarring or turning the raw sensor data into usable video, but they're going to be moving the decoding as well from the CPU onto the GPU. The SDK for that is actually already available. We're just waiting for Blackmagic and Adobe and Avid and all those guys to actually integrate it. I actually expected this to happen months and months ago. It hasn't happened yet, so there's probably some little roadblock or they want to do extra testing. But once they do that, the CPU is going to be a lot less of a deal for red footage. It's going to be even more about the GPU. The demos I've seen, at last like NAB, they had just a low end, like a 6-core, just pretty basic CPU, like $400 CPU, and they were able to decode Red 8K or actually play Red 8K in real time with a Quadro. I think it was an RTX 6000. So that's about equivalent to a 2080 or 2080 Ti on the GeForce side. So just keep that in mind. If you are looking, or if you do a lot of work with red footage, you might want to step down your CPU a step and step up your GPU a step. There are some things we don't know. We don't know if it'll be able to handle multiple GPUs. We don't know exactly how the relationship is going to be between the CPU and the GPU. But we can make a little bit of guesses, and so just get a little bit more GPU power than you would generally get if you are working with red footage. And then I'm going to really briefly, I'm already over time by a minute here, go through kind of the other things that we recommend that you keep in mind. Deck link cards or other video out cards are important, especially if you're doing color work. If you're outputting through a video card, it goes through like the Windows layer, it goes through the driver layers, and the colors can get tweaked a little bit as it goes through those. So these video out cards to like a secondary reference monitor is a great way to get a unbiased, I suppose, video signal. And then along with that, high quality monitors. Obviously, you want really high quality monitors if you're doing video work. There's tons of great brands out there. Even like HP and Dell make really great monitors, actually. But if people are looking for brands, we generally say, BenQ or Benq, however you're supposed to pronounce it. If you're on a little bit more of a budget, mid-range ASO are terrific. High-end, you can get into Flanders Scientific, or there's a few other ones that are absolutely terrific at the very, very high-end, very expensive. But that's kind of our starting points. If you just need something, a place to start. And then there's also audio. Do not, if you're doing any amount of editing, don't discount your audio, obviously. We generally recommend people go with a USB-based DAC. Onboard audio, even if you're using like PCIe sound card, you can sometimes get signal noise. So just interference from everything else on the motherboard. I mean, computers are very complex. There's a lot of signals going around. And so you can get like little jitters or hisses or just little signal noise if you are using anything internal to a computer. So we recommend using a USB DAC. M-Audio and JDS Labs are great entry brands. There are, it seems like hundreds of brands out there. A lot of them are super awesome. So you can really, there's a rabbit hole to go down there when it comes to audio. And along with that, you'll also consider your speakers, headphones, and all that kind of jazz. Okay, so I'm going to do a brief summary here in a second, but I do just want to put on again that there is that question and answer. It looks like we've got a few questions we can go through, but if you do have one, make sure you stick it on. And I don't know if we'll stay enough time to answer all of those, but we will try. And then I believe we're also going to launch a poll here in just a minute once we start actually getting into those questions. Definitely, if you can fill that out, that helps us a huge amount. Just help us tailor these webinars exactly for what you guys find useful. So brief summary while people are putting in some questions. Storage and RAM is your first concern. Storage is about capacity and speed. RAM is really just about capacity. CPU and GPU are your consideration for performance. Does not scale linearly. Spending twice as much on a CPU or GPU does not mean twice as much performance. And multiple GPUs, as much as people love to talk about that for DaVinci Resolve, it really depends on how much open effects and noise reduction you do. If you don't use those much at all, multiple GPUs probably aren't going to give you any sort of performance benefit. Don't neglect your display, audio, and other devices, obviously. I mean, your computer is one part of your workflow. If you spend all of your budget on your computer and your monitors are terrible, well, that's going to be a little bit of a burden on you. So keep that in mind. And of course, we're here to help. I mean, workstations are what we do. So if you just want to focus on your work, get your work done, leave the hardware to us. I mean, we're here to do that. We're excited about the work you're doing. We want to enable you. We want to help you, get your work done and forget about the computer. The computer should just sit down there and do what you need it to do. Okay, so there's a little bit of information, and we will go through these questions here. Okay. And Oscar, if you're on here, if you could launch that poll here just while we're going through these questions, that'd be great. Okay, so the first question here. So they're talking about they work with high-speed film and the potential of getting into Fusion. The biggest challenge is smooth previewing and effects in the timeline, and any suggestions for CPU, GPU, RAM combo. It depends on how much actual Fusion work you're doing. Like I mentioned before, the 9900K is kind of the best CPU possible for Fusion. So if you're doing that kind of stuff, Yeah, that's going to be it. Generally, you're not going to be getting real-time playback of anything Fusion-based in the timeline. It's just not going to happen. The only way to really get that is to render it out. And I know you can actually render directly from Fusion. You can put in a render node, and then that'll output that to a file, and you can import it if you don't want to actually like make a timeline and then go to the deliver tab and all that. So you might want to look into that. As far as GPU, it sounds like for what you're doing, the GPU is not going to be as big of a deal. So it's even a mid-range GPU like the even probably the 2060 Super would be fine. I think a lot of what you're talking about, hardware isn't going to be a solution to the problem. Unfortunately, there's only so much hardware it can do. Best CPU for debugging red files. So we talked about this a bit, where soon the CPU isn't going to be as important, but right now, for what we have at the moment, is probably one of the higher end X series. So we talked about the 9920X, the 12 core, or the 9960X, the 16 core. If you can it's pretty much whichever one you can afford. You don't need multiple GPUs for that, so you probably want to stick with something like a 2080 Ti GPU, and then whatever the highest end X series you can afford right now. That's what you're going to be looking for red at the moment. Let's see. We got another question here. They said they're working in Resolve 16 6K timeline. They have a Threadripper 1950X and a Radeon 7, and they're having a lot of issues with render caching and lagging when previewing at times. They recommend changing their CPU platform or their GPU. Honestly, most likely it's the CPU. The Threadripper line, either the first generation like what you have and the second generation that's available now, the main issue with those CPUs is they have tons of cores, but each one of those cores is not necessarily all that fast compared to Intel. And we have had people in that exact same situation. And yeah, we ended up moving them over to an X series platform, an Intel X series. More than likely, your GPU is just fine. Again, the Radeon 7 is a terrific card. I think it might be one of the fastest cards you can get for Resolve. And all the issues we've had are with like blue screen issues. So if you're not blue screening, it's probably not the card. So yeah, it's probably just the overall Threadripper platform is not really all that great for DaVinci Resolve, unfortunately. Another question of what is going to be better, 3800X, that's a AMD Ryzen 3800X plus 2070 Super, or a 3900X plus 2060. I think that's going to depend. If you are working with H.264, H.265 media where you have the GPU-based decoding, I would go with the 3800X plus 2070 Super. If you are doing like ProRes or Red, then you might want to go with the 3900X plus just the 2060. I would say though, if you can spend that extra $50 for the 2060 Super, do it. It is well worth it. In general though, the performance difference between the 3900X and 3800X is not all that much. So I would probably go in a vacuum without knowing everything else about your workflow, the 3800X plus the 2070 Super. No, we've got 4 more questions here. We're just going to go through them. Feel free to head out if you need to head out, or we'll go through these. We had a question. Oh, this is more about Puget systems, but why are the super cards not listed for our system configs yet? Availability is not quite there yet. That's pretty much it. We've already fully qualified them. It's just they aren't actually as available as we would like them to be. If you do want one, you can talk with one of our reps. They can either see if we can get you on one early, because again, we've already qualified them, or they can just put you on a list and we'll let you know when they are actually available. And that's actually true for a bunch of other things too. Like we're not listing the AMD Ryzens quite yet due to availability, and we think we still have a few qualification things to get through. CPUs in general platforms require a lot more work to go into, because we want to make sure that it's all solid and all the launch bugs are worked out before we actually list on our page. So you'll almost never find us listing things the same day they're launched. We're generally a week, sometimes even up to a month or 2 behind. Any thoughts on the upcoming 3950X with 2 2080 Ti's, or wait for the new Threadripper? So the 3950X, for those who are not familiar, it's a new Ryzen CPU. I believe it's going to have, is it 16 cores or is it 12 cores? I forget exactly how many cores, but it's a even higher core count. It's not out yet. I think it's supposed to be launched this month though. versus the new Threadrippers. Really hard to say. I would bet that at the same price point, so whatever the new Threadripper is, that's going to be the same price as the 3950X. Probably the 3950X will be faster for DaVinci Resolve, especially if you're only going to be using two 2080 Ti's, because you'll have plenty of PCIe lanes to power those two 2080 Ti's. The new Threadrippers, though, are looking very interesting. Generally, the problem with Threadripper has been the single core performance. The new Threadrippers are supposed to fix that. Problem is they're not out yet, so we don't know. We will, of course, be doing testing when it comes out. We'll be doing testing with 3950X when it comes out. You can actually subscribe to our newsletter and get emails whenever we launch new articles, see if you want to keep an eye on that. My bet, though, is going to be that the 3950X will be the better option at that price point. You'll be able to go higher end with Threadripper. Threadripper will also let you use 3 or 4 GPUs a lot better because they'll have more PCIe lanes. But if you're just talking about 2 GPUs, probably the 3950X would be the way I'd go. Sony Venice camera creates 6K H.264 16-bit. Do you need an NVMe drive for this, or will a regular SSD be okay? Depends on the bit rate of the media. That's really all it is when it comes to is a drive going to be fast enough for your media? I have no idea what the bit rate is for that camera. It should be listed in the specs. You can also just look at the total file size versus the length of the video, and then just divide the two to get the bit rate. But you'll only need an NVMe drive if the bit rate of the video is more than probably, oh man, I'd have to remember exactly what it was. It'd be somewhere around 2000 megabit, which I doubt H.264. I don't even know if it's capable of anything that high. So no, you shouldn't need an NVMe for that, but I would double check on the bit rate for that. Is there any advantage to using a fast NVMe drive for the operating system over a standard 500? They say megabit per second, but again, this is where you get, and the problem is 500 megabyte per second solid state drive. So NVMe for OS drive. Yeah, it makes a small difference. Launching programs will be that tiny little bit faster. Definitely not like 7 times faster or anything like that. You're probably looking at 10, 15%, a little bit snappier. It's generally not a big deal, although we do have some NVMe drives now that are the same price as standard SSDs. They're not as fast as the high-end NVMe's, but we are starting to use those more and more for OS drives. It's also nice because NVMe drives, they plug directly into the motherboard, kind of like a video card does, so there's no cables, which means less points of failure. So that's another thing to keep in mind is NVMe's are great for that if you're going for one of the not as crazy performance ones. Okay, we're getting more questions. I'm just going to stay on the line and I'm just going to answer these. I'm just going to get all of them. So so I'll just say thank you right now for anyone who attended this webinar. We will send out a recording afterwards if you wanted to double check on anything. And all of this information really is available in all of the content we put out on our DaVinci Resolve workstation page. There is a tab for hardware recommendations, and generally most of the same stuff that we talk about here is in that tab. Not quite all of it, because we gear that towards the parts that we actually are selling in our systems. Like we don't have the new Ryzens yet, so we don't talk about Ryzen in there. But definitely check that all out. And thank you everybody for attending. All right, so let's work through all of these. Eric, oh man, I want to check here. I want to get all of the Resolve ones first, and then I'll talk about the hardware ones afterwards. So they're moving GH5 422 10-bit H.264 files in DaVinci. So that's actually about performance for that. So you can do, I believe the GH5, when you talk about 10-bit, you're going to be 100 megabit per second is the highest bit rate for that on that camera. Right now, you should be able to do that even in Premiere without having to transcode, depending on how many effects you're putting on. If it's just Lumetri and that's it, you should be fine. If you've got like multiple video layers with like some opacity, you might run into issues. DaVinci Resolve tends to have less issues with that. You mentioned you have a 9900K and a 1080. That should be enough to even do it in Premiere. So if you're having issues in Premiere, it's probably because of everything else you're doing. I mean, unfortunately, timelines are never as simple as a single video file. DaVinci Resolve should have a bit better time with that, simply because it uses the GPU for decoding H.264 media. The other thing you can try, this is getting a little bit outside of DaVinci Resolve, is make sure you have onboard video enabled on the 9900K, because then you can enable quick sync, which allows you to do Intel-based decoding of H.264 in Premiere Pro. So you might want to double check, make sure that you do have quick sync enabled and have that enabled in Premiere Pro before you worry about switching programs. But the problem with moving to DaVinci Resolve is that since the free edition doesn't have the GPU-based decoding, it's going to be hard to tell whether it is actually faster. You might want to just try to find someone, a friend or a coworker who has DaVinci Resolve Studio, and see if you can just send them a test clip or a test project to see how that'll go. Let's see here. Oh, okay. This was a fix or another suggestion to the 10-bit 400 megabit. Okay, if you're going up to 400 megabit in DaVinci and Premiere, that's probably a little bit too much for both. I don't know if you'll be able to do that without transcoding, to be honest. NVMe drive for Resolve cache, absolutely. I would do that. We recommend that for people doing like a disk cache in After Effects as well. It can make a pretty big impact. It's not as much from the reading side. Reading, cached files is not a big deal for an SSD. It's about writing. So it actually will, I think it's a bigger deal in After Effects than Fusion, but I would still do it. And I do a dedicated drive. Since you are putting so many of these tiny cache files, it can degrade the lifespan of the drive a little bit. So you do want to make sure you get a, like if you're going with a Samsung drive, get their Pro line instead of their Evo. It has a much higher endurance. In the end, it'll end up costing you less money because you'll have to replace the drive less often. Let's see, a couple more. NVMe bridge, does it help or hinder Resolve performance and reliability? It hurts. Do not use it. In Windows, NVLink needs SLI to be enabled. And right now, with the current versions of Resolve, if you have SLI enabled, so that's allowing two video cards to kind of work as one. And well, SLI is for 3D applications, like video games. NVLink is supposed to be for compute stuff. But right now, since it uses SLI, Resolve will actually only see one of your video cards rather than both. So do not use SLI right now. Hopefully that's something they'll fix, because NVLink allows a lot of really cool stuff to happen, but it's not currently used right now, and it will make your performance really, really bad. So don't do that. Hardware necessary to have 4 1080p layers in the timeline playback smoothly. It's going to be CPU primarily. The GPU will make a little bit of an impact if you're using H.264 there, but generally your bottleneck is going to be CPU. Unfortunately, without actually testing the exact files you have, it's hard to say exactly what CPU is available or will be best for that. This is a good opportunity to mention that we can do that kind of testing for our customers. So if you are getting the system through us and you want to make sure that it's going to be able to do what you need it to do, you can toss us a test project, share on whatever file sharing you have, Google Drive or whatever. We can download it. We can run it on a system here to make sure it'll give you the exact performance you need. Sometimes we can even do a little bit of light comparison between multiple CPUs. We do have to be careful that we don't spend too much time on that, because our time is finite, but we can do some quick tests for you if you want to make sure that the system will be able to do what you need it. Says you've seen that NVMe has lower CPU utilization under load than SATA SSDs. That's not something we've really seen. It's not something we've really looked for either. That wouldn't, well, I don't know, would that surprise me? Because SATA drives are going through a SATA controller. NVMe will go directly to the CPU or through the chipset. I've never seen it be a significant enough difference to actually cause any difference in performance. That wouldn't surprise me though. Let's see, is there any more in here? Any communication problems with an Intel chip and a Radeon card, or AMD Threadripper and an NVIDIA card? No, not really at all with the current stuff. It's possible that things can change in the future. Intel has talked about releasing their own video cards at some point, and AMD obviously has both the CPU and GPU. They could do some sort of special sauce in the future. Currently today, right now, no, it doesn't make any difference whether you have Intel or AMD CPU paired with an AMD or NVIDIA video card. Another question on hardware, asking about the 5700 and 5700 XT. Those are from AMD, so AMD Radeon 5700. They are honestly really bad for Resolve. They are geared towards gaming. They're not geared towards professional loads. It's not really previous gen, but their Vega series, the Vega 56 and Vega 64, those are much better for DaVinci Resolve. Yeah, the 5700 and the 5700 XT are just frankly not great. They're slower than, I think they're the slowest card we've tested for DaVinci Resolve. We don't go much lower than the RTX 2060, or those cards are kind of the lowest end that we tend to test. But yeah, they're the bottom of the stack. I would, in a heartbeat, go with a 2060 or 2060 Super over either one of those. A lot more hardware based. Air-cooled versus liquid-cooled. We almost exclusively do air-cooled these days. Liquid cooling your CPU in particular can be helpful if you have 4 video cards in a system. So if you are going to be doing a Resolve workstation with 4 GPUs, or sometimes even 3, we do go up to the liquid cooled sometimes. But in general, it's actually not that big of a deal until you get into things like overclocking, which we tend to not do. So if you want to do overclocking yourself, you might want to go with the water cooled. The biggest thing you get out of liquid cooling is you can put the radiator somewhere where it can get fresh air, so it can go right on the side of your case or like the back of your case and pull fresh air straight in. And you can get just larger radiators. In our systems, it tends to not be that big of a deal. I mean, as long as you're not to the point where you are not getting the maximum turbo boost speeds, it doesn't really matter. CPUs last so long anyway that a few degrees isn't going to make a difference for longevity. Okay, are there any others here? General Resolve performance, 1080 Ti versus 2070. That's going to be really, really close. I think it's been a while since we've actually done that test. The one thing you can do is you could download our DaVinci Resolve benchmark. Not sure if it's, I'll put in chat a link to it. So you can just go download that and then compare the scores or the results. Oh, and I sent that to the wrong person. There we go. You can download that and compare that to the results in our latest articles. But I think they're going to be pretty darn close between those two, 1080 Ti versus 2070. If you were talking about the 2070 Super, which is the same price, I believe, as the 2070, then you'll probably edge out with the 2070 Super. Okay. A lot of thank yous. First webinar that's not pre-recorded. Thank you. Well, happy to do so. If you're watching this later on YouTube or whatever, this is kind of pre-recorded for you, but not everyone else. Yeah, the build is great. 3800X 2070 Super. It should be terrific for 10-bit H.265. 32 gigs of RAM. It should be great. Okay, well, thank you everybody for attending. Again, I believe we'll be sending out a recording to this webinar if you'd like in the future. If you have coworkers, friends, or anyone, we'll also have a registration link if they want to view it themselves as well. So same registration you went through to attend this webinar live. Okay, thank you very much for attending. This is terrific. And we are going to be trying to do these webinars more often about different software applications. I'm not sure what our next one will be, but definitely keep an eye out for that. Okay, thank you, everybody.